Hello everyone, this is Group 6 of Division R and we are here to explain the topic Direct Memory Access. What is Direct Memory Access? DMA or Direct Memory Access is a technology that enables certain hardware components to directly access a computer's main memory without the involvement of the CPU. DMA allows the CPU to perform other tasks while data is transferred rather than being occupied during the entire process, as in the program input output. An interrupt from the DMA controller indicates completion of the transfer, which is initiated by the CPU. History of DMA. DMA was invented by Gary Kildall, an American computer scientist in the early 1970s. He was one of the founders of the Digital Research Incorporated, a company which developed the CPM operating system and developed the first DMA controller called the DMA controller chip 8237. Principles of DMA. There are two principles of DMA, which are standard DMA and bus mastering. Standard DMA. Standard DMA refers to the ability of a device other than the DMA controller to initiate DMA transfer. This can be device like graphics card, network card, or any other device that has DMA capability. Standard DMA is also called as third-party DMA. Example, a network card in a computer system can use DMA to transfer data directly to main memory without involving the CPU, thus offloading the CPU from the task of data transfer. Bus mastering. This principle refers to the ability of the DMA controller to take control of the system bus, allowing it to directly access the main memory without involving the CPU. Example, a disk controller on a computer system can use bus mastering to take control of the system bus, allowing it to directly access the main memory without involving the CPU. This can increase the speed of the data transfer between the disk and memory. Modes of operation. There are mainly three modes of operation of the DMA: burst mode, cycle stealing mode, transparent mode. Burst mode. In this mode, the DMA controller transfers multiple words of data in a single burst cycle, which can increase the speed of data transfer. The number of words transferred per cycle is typically referred to as the burst length. Example, a graphics card using DMA to transfer video data from memory to the display. The graphics card uses burst mode to transfer multiple words of data in a single burst cycle, allowing for faster data transfer. Cycle stealing mode. In this mode, the DMA controller takes control of the bus during idle cycles when the CPU is not using it to transfer data. This allows the DMA controller to transfer data without disrupting the CPU's normal operation. Example, a network card using DMA to transfer incoming network data to memory. The network card uses cycle stealing mode to transfer data during the idle cycles of the CPU, allowing for efficient use of the bus without disrupting the CPU's normal operation. Transparent mode. In transparent mode, the DMA controller appears to the CPU as if it were the peripheral device. This allows the CPU to access the peripheral device without the need for programmed input-output instruction. Example, a disk controller using the DMA to transfer data between a disk drive and memory. The disk controller appears to the CPU as if it were the disk drive, allowing the CPU to access the disk drive without the need for programmed input-output instruction. Specific modes of operation and their exact implementation may vary between different DMA controllers and systems. Limitations before DMA. Disk controllers. Before DMA, disk controllers used program input output, which was slow and occupied the CPU. After DMA, data transfer is faster and in background, freeing the CPU for other tasks. Similarly for network card, graphics card, and audio card. Advantages of DMA. First, increased performance. DMA allows for faster data transfer between peripherals and memory as the CPU is not involved in the process of data transfer. Second, reduced CPU load. DMA offloads the CPU from the task of data transfer, allowing it to perform other tasks. Third, increased system responsiveness. DMA allows peripherals to transfer data in the background without interrupting the CPU, which can increase system responsiveness. Fourth, simplified programming. Transparent mode of DMA allows the CPU to access peripheral devices without the need for program input-output instructions, which can simplify programming. Disadvantages of DMA. First, increased system complexity. DMA requires additional hardware such as DMA controller, which can increase the complexity of the system. Second, increased system cost. DMA requires additional hardware, which can increase the cost of the system. Third, limited system memory. DMA can only transfer data within the limits of the system memory, which can limit the size of the data that can be transferred. Fourth, security concerns. DMA could be maliciously used to gain unauthorized access to the memory and thus can create security vulnerabilities. Thank you.